Hello and welcome to another edition of Brain Maths. In this video, we want to look at how to determine the determinants of 3 by 3 matrices. In our previous lessons, if you don't forget, we tried to look at the determinants of 2 by 2 matrices, and I told you in that lesson that what we have done will be needed when we get to 3 by 3 matrices. And here we are today looking at the determinants of 3 by 3 matrices. The first thing we need to understand here is some basic terms which will help us during the course of this lesson. The first one is what we call the minus. Is the determinant of 2 by 2 matrix gotten after covering the elements we are using. Okay, now if you look at this from what I just said now, after covering the elements we are using, assuming we are starting with row 1 and I have covered 2, then you cover the row and the column of that 2. The remaining elements that is left will be a 2 by 2 matrix. The determinant of that 2 by 2 is what we refer to as minor. If you are using 4 as an example, if 4 is being used as an example, we are going to cover the row of 4 and then the column of 4. So what do we have left? We have 3, 6, 2, and 4, which is going to give us another 2 by 2. So the determinant of that 2 by 2 that is gotten is what we refer to as the minus. Then, the other thing we need to understand is what we call the cofactors. The cofactors are just the sign that will be placed in front of each of these minus. After getting the determinant and you are using the element that is covered, then the sign that will be in front of that element and the minor will be determined by the cofactors. So the cofactors are just signs like plus, minus, plus. Since we are using 3 by 3, so we have minus, plus, minus, plus, minus, and the plus. Now, what we are saying here is that for this first one, okay, let's take the 4 that we have just underlined. Since we are using 4, the row of 4 has been covered and the column has also been covered. So we are going to be having 2 by 2, 3, 6, 2, and 4. Now, look at where 4 is. 4 is on A1, 2. This is A1, 2. This place is A1, 2. Meaning that whatever we are getting from this place, the sign that will be in front of that answer, after you must have gotten the determinant, which is 3 times 4, 12, minus 2 times 6, another 12. You multiply and then find the sum of this. 12 minus 12 is 0. So by opening this, we are going to be having a negative in front of that. Assuming we are using 2. If 2 is being used, then the sign that will be in front of that 2 will be a positive sign. And if we are using 7 as our element, the sign that will be in front of 7 will be another positive. Assuming you are now using row 2. The first sign for row 2, if you are expanding along row 2, the first sign for row 2 will be negative. The second sign will be a positive for 5, and the third sign will be another negative. So let's try to find the determinant of this matrix A. Don't forget that we can find the determinant by expanding along any row. If you're using row 1, you expand along row 1 using these cofactors. If you're expanding along row 2, you use the cofactors for row 2 and also cofactors for row 3, as the case may be. So now, the determinants of A. Determinants of A. Okay, let's expand along. Expanding along row 1. So if we are expanding along row 1, this is our row 1. The first element on row 1 is 2. So the determinants of A will be these 2. You write it first, and then you cover the row of 2 and then the column of 2. We are left with 5, 6, 0, 4. This positive sign is here. We don't have to show it because it is positive. Then the next one is 4. We are covering 4. When you cover the row of 4 and the column of 4, we will be left with 3, 6, 0, and 2. So you write negative cofactor minus 2, minus 4 rather, since we are using that, minus 4. Then what do we have left? When you cover this, 3, 6, 2, 4. 3, 6, 2, 4. Also, the last one is 7. The cofactor for 7 is positive, so we have plus 7. And when you cover for 7, you have 3, 5, 2, 0. 3, 5, 2, 0. So, the next thing is to find the determinant of each one of these. So, the determinants of a 3 by 3, which is A, is 2 into 5 times 4. That is 20. Minus 0 times 6, 0. Minus 4, 3 times 4, 12. Minus 2 times 6, 12. Plus 7 into 3 times 0, 0. Minus 2 times 5, 10. If you don't forget what we have done in our previous lesson, when you have a 2 by 2, this is how you get their determinants. So we have 2 into 20 minus 0, 20. Minus 4 into 12 minus that, 0. Plus 7 into 0 minus 10, minus 10. So when you open that bracket, you have 2 times 4, 2 times 20, 40, minus 4 times 0, 0, plus times minus, minus this 7 times 10, that is 70. So we have 40 minus 0 minus 70. And that is the same thing as 40 minus 70. And 40 minus 70 will give us minus 30. So this is the determinant for matrix A if you expand along row 1. Now, assuming you are expanding along any other row, the thing is you must still get the same answer anyhow you go about it. So let's take row 2 as an example and see if we are going to get the same answer. Now expanding along row 2. Now we are expanding along row 2. Now the row 2 is going to take negative, positive, negative. That is the cofactor for row 2. Now let's start. The determinant of A expanding along row 2. The first one will be minus 3. Now, if you cover the row of 3 and the row of 3 and column of 3, we are left with 4, 7, 0, 4. 4, 7, 0, 4. Also, the next one is plus 5. And if you close the column and the row of 5, you have 2, 7, 2, 4. 2, 7, 2, 4. And the last one is minus 6. If you close the row and the column, you have 2, 4, 2, 0. 0. Now, let's do justice to this as well. Now, we have the the determinants to be minus 3 into 4 times 4, 16, minus 0 times 7, 0, plus 5 into 2 times 4, 8, minus 2 times 7, 14, minus 6 into 2 times 0, 0, minus 2 times 4, 8. Now let's see if we are going to come up with the same answer. Minus 3 into 16 plus 5 into 8 minus that. That is going to give us minus 6. Minus 6 into 0 minus this, minus 8. So we have the determinant of A to be minus 3 times 16. That is minus 48. Plus times minus, minus 5 times 6, 30, plus minus times minus, plus 6 times 8, 48. And it is obvious that minus 48 and plus 48 will give us 0. So we are left with the determinant of A is minus 30. So from what we have said, if you go with the third row, if you expand along the third row, you are still going to be left with the same negative 30 as your final answer. So the thing you need to be conversant and be watchful of are just two. The first is how to get out your minus, and the second is knowing the cofactors to use as the case may be. I am going to leave you with this question on the board saying if P is a 3 by 3 matrix with these elements, you are expected to find the determinants of P along rows. The first one is row 3. Expand along row 3 and let us see what you have as your answer. Also expand along row 2 and let's see what you will come up with as your final answer. Until I come your way again, don't forget to subscribe to this channel if you have not done so, and also share this video to as many people and platforms as possible. Do have a blessed day.